welcome to lesson number 5 in the After Effects Expressions training series. This lesson is going to focus on control of expressions. Now that we know how to make expressions, how do we control when they happen? So let's construct this spooky little title sequence here. And in doing this, you'll see a lot of examples on how to control your expressions. Alright, so let's quickly set the stage here for our spooky title sequence. Now, I'm starting out with an image from Riot Gear. This is Grunge number 8. This is the large version, and it looks like this. Sort of a rusty door. And I've done a pretty extreme level adjustment on here where I've taken the blacks and done a very severe crush on them. Also, I've added a point light to the scene, and I've added an adjustment layer which has some glow and a level adjustment to add just a little bit of a green cast to everything in the scene. Now I've brought the gamma of the green to give just a little bit of a green hue to things. I've also added a little bit of fog using fractal noise. And that's just using a screen transfer mode and a little bit of mask. And that's really it. All of this stuff is included with this lesson, so feel free to take it apart and modify it as you need. In fact, I'm going to turn all these layers here that I'm not going to be using into shy layers so that they're not interfering with my comp here. What I'd like to have happen is this light will flicker. However, I'd like it to start dim, as if the light is off, and then the light is turned on and the light begins to flicker. So the flicker part is pretty easy. I can go into the intensity and just have it wiggle, perhaps 4 times a second, so it's pretty erratic. And we'll have it 40% in either direction. So this is going to flicker up and down 40% 4 times a second. What I'd like to do, though, is control when this happens. Like I said, I'd like it to be off for the first 2 seconds. So we already actually have all the skills we need to be able to control this using the most simple method, which is using an expression control. So if I go up to Layer, New, Null Object, I'll hit Shift-Command-Y to get the solid settings on here, and I'm going to call this controller. Now, to this controller, I'll apply a slider control, and I'll rename this by hitting Return, and we'll just call this Light. Now, what I can do is drop this wiggle down 1 line and declare a variable of n to be equal to this slider control up here. And type my semicolon, and then instead of having a fixed amount, I can have this be n. So now I can freely keyframe this slider and control the amount of wiggle in the light. We're going to take this a lot further. If we were going to have a flickering light, the light would flicker occasionally, not every single frame. So we would like to define a certain probability for this light to flicker. Also, what we're going to do is define a point in time where it starts to flicker. So we're going to have the light more or less be off and the scene is going to be dim, and then we'll have it turn on and then begin to flicker. So we need to be able to control this event, and we need to have a value that we can define before the light turns on, and then a value afterward, as well as adding this random flicker that we can define the probability of. Sounds a little tricky, but it's actually pretty easy, and this is just going to be using basic random number generators and a new term that we haven't used called clamp. Clamp pretty much does exactly what you would think. It clamps a value between 2 values that we define, and we type this in expressions like clamp, and then in parentheses we type a value and the range that we'd like the value to be clamped within. So this term here will output a number based on these values here. So if we set v equal to clamp of a value t, and we clamp t between 0 and 1, v is now going to be equal to a clamped value of t between 0 and 1. Now, if I were to feed a value of 1 into t, v would equal 1. If I were feeding 0 into t, then v would equal 0. No big deal. However, as t decreases below the clamp value, it maintains this clamped value here because it will not allow the clamped value to go below value 1. And the same goes for value 2. It will not allow it to go above value 2. So no matter how much t would change, v is always going to be clamped between these two values that we define here. So let's say we take a value of r and assign that to a random value between 0 and 1, and we round that off to the nearest integer. So r is going to be either 0 or 1 on every single frame. So let's think of this as off and on. 1 is on, 0 is off. If we were to expand the range of this number generator to -1 to +1, and then run it through a clamp, so we generate a number, and then we set something else like v equal to be a clamped value of r between 0 and 1. So as this random number generator generates numbers, there's a possibility that it will be below 0. However, it could also be somewhere around 0, or it could be around 1. So now we've got a 1 in 3 chance that we're going to hit a 1. If I were to set this to -2, we would have a 1 in 4 chance that we would hit a 1. We can have this go all the way out to -4. Notice this is 6 digits. Therefore, we would have a 1 in 6 chance of hitting a 1. This is a very simple method of defining probability in an expression, because essentially we just have a 0 and a 1. We could use this perhaps as a multiplier. I could multiply a value by v. V is 0, it would turn the value to 0. V is 1, it will just leave the value alone. So let's apply this probability technique to the scale of this text object right here and see how this looks. So create an expression for scale. And just like the example, I'll declare a variable of r equal to a random number between -1 and +1. And actually what we need to do is round that. So I want to do math.round and then put all of that inside parentheses. So we have a rounded value between -1 and +1. Next, I'll set v equal to a clamped value of r, and we'll clamp it between 0 and 1. So now v is always going to be either 0 or 1, but the odds are that it's going to be 1 are currently 1 in 3. If I jump out, take a look at this again. Remember, 1 in 3 is when we generate a number between -1 and +1. I'll conclude this by just adding a simple wiggle. That wiggles 10 times per second. This is going to be a fairly abrupt wiggle. And we'll have this, multiply 400 by v. V is either on or off, and that will multiply times this wiggle. So if I play this, we're going to see some fairly abrupt jitter. Now we can actually smooth this out a little bit by removing the rounding function, because this is really clamping the value down to either 0 or 1. There's really no area in between. So if we'd like to smooth this out a little, we can actually remove this rounding function, and we'll see a little more randomness and jitter. So it pays to know both ways to do this. We can have the rounding function on and have exact probability of 1 in 3 or whatever we can define. But when we're dealing with some sort of transformation like scale or position, which I'm about to do, you might want to remove the rounding function. It's great to explain the concept of probability, but in all practicality, when we're dealing with a transformation function like scale or position, we probably want to remove it. All right, so let's get in here and tweak this just a little bit to make it a little more user-friendly. I'm going to define a variable called probability, and we'll set this equal to 4. Now, ideally, if we say 4, we would have a probability of 1 in 4. So if I go down here, I'm going to use this probability variable as my range. So notice I'm leaving the negative sign in here. So if I'm saying a probability of 4, we are going to use a negative version of that. Remember, over here we had, let's say, odds of 1 in 4 start at -2. So if we want odds of 1 in 4, and I declare my variable to be 4, we actually want that value to be -2, not -4. If I wanted 1 in 5, this would be 3, not 5. It's actually just 2 off because of our 2 extra digits up here. So I'm going to add 2 back onto our probability. So when I type this probability in here, I know that when I type 4, it's actually going to be 1 and 4. So I'd like to apply this scale expression that I've got here to position. So if I look at my position and apply that same expression, and I'll disable this scale expression, we'll find that this works pretty well. If I play through this, we'll see that it's wiggling at the same probability, and it's wiggling in X and Y independently, just like this scale was. So for either of these, we should know how to have this only wiggle in one axis. So for position, I'll have this only go up and down, go in the y-axis. So don't forget, wiggle is equal to the existing value of our property plus some variance. So right now, S is equal to a 2-dimension array, and it is adding some variance with these values over here. So that existing value is 2 dimensions, so S has 2 dimensions. Remember, X would be the first value, which is labeled as 0. Y would be the second value, which is labeled as 1. So I want to get S1 as my Y value. So I'll just assign Y to S1. And then I'll make X equal to the existing position value. That would be value 0. So now I've got X and Y declared. I can just go down here at the bottom and put X and Y as my final value. Now if I play through this, this is just wiggling in the Y-axis. Now if I modify this probability, if I make it 10, this would be a 1 in 10 chance that it would wiggle. If I set this to 2, this is actually a 1 in 2 chance on every frame that it's going to wiggle. So it's going to wiggle quite frequently. Now let me show you one other cool thing we can do with this exact same expression. Now I've disabled these scale and position expressions, and I'm going to go into the type animators here. So I'm going to go to the animate pop-up and select scale. Now I'm going to go to animator 1, range selector, and go into the advanced section here. I'm going to change the units from percentage to index. Index simply means that this range is now based on the number of characters in the type rather than a percentage. So if I were to set this to a start and end value of 0 and 1, that means that we would only have one character selected at a time. So let me turn up this scale for this animator to 150%. We see that our character is a little bit larger, and now I can make a wiggle function for this type. So if I set this to 3 and 3, I have a frequency of 3, so it's 3 times a second, and an amplitude of 3. So it's only going to move 3 characters in any given direction from its starting point. That means I want to make sure that its starting point is right in the middle. So that would be an offset of 3. So it's going to move 3 in either direction. Now, what if I were to change this word and it were no longer 3? This isn't a very flexible expression because it's a fixed value, and we'd have to change this every time. So what do we need? We need the number of characters in our type more or less divided by 2. So in our last lesson, you learned how to get the length of an array. In this case, we can use that same command to get the length of a text string. So what I'm going to do is bump this wiggle function down to, and I'll assign a variable t equal to the source text. So t is whatever type I write up in here. Now, n is going to be equal to t.length. So n is now the length of t. If t were an array, it would be the number of dimensions in the array. However, it's just a piece of text, so it is equal to the number of characters in the string. So right now, n is equal to, if I disable this, 6. So if I divide that by 2, that would be the halfway point, even if we made this a much larger word. if we're 18 characters wide, the halfway point would be 9. So, get rid of this. So now, what I want is to have this wiggle function use n instead of 3. So now, I can recycle this expression on any word that I want, and the offset is going to be set on each word exactly right. Now, notice that every time it moves through these, the scale is changing. What we are seeing is that this scale is always set to 150%. So what we need to do is take that expression that we've had written for our other properties and plop it right into that scale. So if I go into my scale here, in fact, let me twirl advanced closed, we'll create an expression for this letter scale. And what I want is for x and y not to be moving independently. Now let me set this back down to 100% as the default value. And we play through this right now. Oops, because I copied this, it is now enabled again. So if I play through this, we'll see that these characters are wiggling in x and y, which is kind of a cool effect. But I'd like to lock x and y together. So one way to do that would just be to grab the first value of this s, which is, again, an array, so we'll just grab the first part of it and use it twice. So s0 and s0 will now become the value of the scale. So now x and y will be locked together because they're the same value. So now if I enable the position expression, it's going to look like this. Now let me point out something else that I did with this title sequence with the names. I've got this goofy name here, Keyframe Sutherland. What's going on here is that this name flies in, kind of sits there and jitters and has all that stuff that we've done so far, and then flies out at the end. Now, notice what happens if I trim this in each direction, make it a little larger. It's still going to fly in and fly out at the end of the clip. What it's doing is cueing itself based on the in point and out point of the clip. So the next thing we're going to study is how to trigger expressions using the in and out points of our layers. Now, the way this is going to cue with the in point and out point is by using a term that we haven't covered yet called linear. And we're going to demonstrate that first by using a simple grow. So this is going to automatically scale from the in point to the out point over time. And then once we get that under our belt, then we'll do the little snap scale expression that happens at the in and out. But let's start small and jump into the world of linear. Linear outputs a set of values based on several properties that we define inside parentheses. And you can see that there are a number of them. Now, ultimately, what it does is output a series of values between this value 1 and value 2 here. Now, you can see I've got an example here where I'd have some values, and I could have value 1 be 0 and value 2 be 20. Now, again, t is equal to this. T is never going to be equal to anything outside of 0 or 20. What linear does is look at this minimum and maximum value that we specify. In my example, I've got 1 and 4. So what it's going to do is, as this value here, which is the rate, moves from 1 to 4, this will output 0 to 20. So I've got this sort of charted out here. As time moves forward and starts at 0, nothing's going to happen just yet. But once time is equal to 1, t is now going to start at a value of 0 and move to 20. So as that value progresses from 1 to 4, t is now going to equal 0 to 20, and it moves in direct relation like this. Largely, I think of this as a remapping function. I can take any sort of numeric range as the minimum and maximum, and then remap these to a new range. So in this case, I am mapping 1 through 4 to 0 to 20. So now I've got my type here, and I've brought this little expression up here over as reference. So let's go down here and type linear and our rate. Our rate is going to be time. So as time moves forward, we need our starting time, the minimum time. So that is going to be where the endpoint of this clip is. Now we could figure that out manually where this is, scrub around and figure out approximately where it starts. Or we could use some sort of expression term that grabs the exact endpoint of the clip, even if it's trimmed. And that is, easily enough, endpoint. Now, I don't even need to specify this comp and this layer. If I just say endpoint, it's going to assume that we are looking at this layer right here. So you can also easily remember outpoint because it's just as easy to remember. It is outpoint. So as time moves from the endpoint to the outpoint, this function will output a number in the range of value 1 to value 2. So like I said, I want to start with the existing value and then go to a value that is 20% greater. So I'm just going to say value plus 20 because our scale is expressed in percentage. I add 20 and 20, which is an array, to this other array, value. Value is a 3-dimensional array, but actually I don't need to enter a value of the Z scale because After Effects has no way to scale a layer in Z currently in After Effects CS3. And if I just simply leave that off, it's just going to add 20 and 20 to X and Y and then leave Z alone. So the only thing I need here is one more parentheses on the outside. So now it should work just fine. At a rate of time, from the endpoint to the outpoint, it's going to output value, which right now is 100%. And it's going to increase to 20% on the outpoint. So next I'm going to look at this snap zoom in and out as the text enters as a very quick snap in, which is just scale, and then it snaps out based on the in and out points of the layer. So I'm going to go into our existing expression here, and we're going to keep this grow. This is fine. We're going to keep that on there, but we're going to add to that a couple other things. So I'm going to assign this to a variable. So grow is now going to be equal to this growing scale that we created. But on top of that, we're going to create an in transition and an out transition. So I'm going to add to this another variable that will be our in transition. I'm going to use the variable in trans, and this is going to be equal to linear, the rate of time, and it's going to create a very quick scale move. So from the endpoint to the endpoint plus just a couple of frames, we're going to have the scale change. So I want to start at the endpoint, and then have the maximum value be the endpoint plus just a little bit. I'm going to use 0.05. So in the time of the minimum to the maximum, so that's the endpoint plus a little bit, it is going to output a couple values that I specify. I'm going to use 400, so it's going to start at a scale of 400. Remember, this is scale, so I need to put an array in here. And I need to move from 400 down to 0, not the existing value. Now, why is that? Well, if I did put the existing value, or even 100%, because I'm adding these together, we would end up with something larger than the original value. Down here, I'm just going to add grow plus the in transition. So this is going to snap in and slowly move over time. If I had this go from 400 to 100, these are adding together. So it's going to add this value here, and it's going to add another value on here. So I don't want to add anything to this. I just want it to return to 0. because I am adding these together. So you can guess that the out transition is going to be pretty similar. In fact, I'll just copy all that and paste it. Make this the out transition. And this is going to not start at the out point. We want it to start a little bit before the out point. So I'll make this the out point minus 0.05. And this will end at the out point. And then we'll get rid of all that. And then we will have this start at 0. Again, we're adding this to it. So we want it to add 0 at first and then have it add a scale of 400. And I need to add the out transition down here at the bottom. And then at the out point, it's going to snap out. One other cool use for this flickering effect is to use it on an adjustment layer. Now, on this adjustment layer here, I used wave warp and grid, and on its opacity, I put this flickering function. So this is either on or off. Now, the way I did this is just by rounding a clamped value and then multiplying it times 100. So as m is either 0 or 1, I multiply 100, therefore the opacity is either 0 or 100. So as this adjustment layer is off, or the opacity is 0, we don't see it. If it's on, we see the effects of this grid and wave warp that I've placed on it. So as it plays, this sort of distortion effect kind of kicks in and out, which I think is pretty cool. So in our next lesson, we'll convert audio into keyframes and use those keyframes to drive the lip sync of an animation in After Effects. So I'll see you in lesson 6.